Hi, I'm Derrick Jensen. This is Resistance Radio on the Progressive Radio Network. My guest today is George Wuerthner. He's the former Ecological Projects Director for the Foundation for Deep Ecology. He's an ecologist and wildlands activist. He's published 38 books on environmental issues and natural history, including such environmentally focused books as Welfare Ranching, Wildfire, Thrillcraft, Energy, and most recently Protecting the Wild. Today we talk again about forest fires because the propaganda for logging the forest because of fire is absolutely incessant, so our resistance needs to be absolutely incessant. So I would like to start just by mentioning the title of an editorial you wrote called "We Cannot Log Our Way to Fewer Fires."
Yes. Well, the gist of that is that what drives, this is the most important overview, what drives most wildfires has to do with the climate, weather, and that sort of is a larger, of course, global and regional level influence than anything to do with fuels or other factors like topography, etc. Not that those aren't occasionally important, but you can have all the fuel you want, and I always use the example of, say, the Tongass Forest in Alaska, where there's huge biomass, but it's so wet that fires just are non-existent there. And the idea that we're going to log our way out of fires ignores that climate influence. And here's what you have to have a fire, beyond just having fuel. You have to have low humidity, high temperatures. Extended drought really helps. It's not absolute, but it helps if you have a drought going on. And then wind. And wind particularly is the most important factor, and the most important factor why logging, thinning, or any of those kinds of solutions do not work and are delusional. And the reason is that during these extreme fire weather conditions, characterized particularly by wind, you have burning embers that will travel often miles ahead of the fire front. And those burning embers, wherever they hit down, ignite new fires, called spot fires. But they rapidly advance a fire, and they also sort of invalidate or make ineffective any kind of efforts to stop the fires. When you have burning embers that will jump a mile or two ahead of a fire front, and you put a bulldozer line or even a shovel line from firefighters there, and you think you're going to stop the fire with those kinds of influences, it's just totally ineffective. Even dropping fire retardant is pretty much a narrow belt that is not likely to affect the wind-blown embers. So we see lots of examples. There was an eagle fire up on the Columbia Gorge in Oregon 2 summers ago, which jumped the Columbia River, which is over a mile wide in that area. The burning embers were tossed across the Columbia River from Oregon and started fires on the Washington side of the river. We see other examples. I was down in Santa Barbara area last winter to take photos from the Thompson fire, which burned through that Santa Barbara Ventura region. And the only fire break that really stopped the fires was the Pacific Ocean. And I half-jokingly say is that that's because burning embers they weren't blown 20 miles out to the Channel Islands. But the point is that a lot of this idea that we're going to stop fires through logging is delusional. It may influence fires, particularly under low and moderate fire weather conditions. In other words, there isn't a lot of wind, or it's not particularly droughty. But those fires never get to be very big anyway. And this is a second important point. The fires that we're trying to stop, which ecologically we probably shouldn't be stopping, but let's assume even if we could stop them, the stopping works under conditions that are not very conducive to fire spread. So the acreage burned annually by fires is the result of a very few fires burning under these extreme fire weather conditions. And the vast majority of fires don't burn much acreage at all. Some statistics I have memorized, roughly, of a study done in the Rocky Mountains, found that over, I think it was a 15-year period, they looked at all the wildfires that had occurred, and 98% of the fires burned less than 4% of the acreage. And by contrast, 0.1% of the fires was accounted for over half of the acreage burned. So it's those very large fires, the Carr Fire recently by Redding, for example, the Mendocino Fire, the Thomas Fire by Ventura is a good example. Those fires account for the majority of acreage burned in any one summer. And most fires actually burn a very small area, and even if we don't do anything, they go out on their own. So the starting assumption that more logging will reduce large wildfires ignores the climate weather influence on it. The second part of that is, what is the probability? I mean, we're not going to log all the forests of the whole West. So what is the probability that a fire will encounter a thin forest? Well, it turns out that the probability is like 1 to 2%. And then you throw on top of that thinning or logging and even prescribed burning is only reduces the fuels for a short period of time. So unless you come back and do annual maintenance or pretty frequent maintenance, in other words, unless you come back and you cut out all the small trees or you reburn it again in the case of a prescribed burner, and if you don't do that frequently, the fuels build back up, and so the effectiveness, to the degree that it might work even under moderate weather conditions, is greatly reduced. And the final thing is that, again, getting back to the kinds of conditions that contribute to a large fire, which, again, wind and drought and drying out of the vegetation, a lot of that is exacerbated by thinning and logging. So you have a situation where the forest cover is reduced, so you get more solar radiation on the forest floor, which can dry out fuels even quicker. You get wind penetration easier. In fact, it's an interesting thing, in a lot of our larger fires, the least burn and the least severe fires occurs in the places where there is the densest forest. That may be contrary to what you might think, but that has to do with that it tends to be cooler and moister, and therefore it isn't as penetrable by wildfire. And so the thinning and logging can often increase the fire susceptibility of a landscape. And even logging roads, they become corridors for, because again there's no trees there, they become corridors for the spread of weeds and grasses, and that are very flammable. What burns in a forest fire is the smaller, finer fuels. That's why you have snags left after a forest fire. That's why you have tall trees without needles on it. But what's burning in the fire is the needles and the small branches, the pine cones, the vegetation on the ground, the grass, shrubs, etc. All those fine fuels is what burns in a forest fire. So if you put in a logging road, as an example, logging roads are a big vector for the spread of weeds and grasses, and so you create these corridors actually in the forest that are even more susceptible to fire and help the fire spread. So for all those reasons, that's the reason why we cannot log our way to fire reduction. The factors that are driving an increased amount of fire on the landscape right now is really part of a bigger global issue of climate change. And the climate change, we are seeing warmer periods. We're seeing springs that come earlier, which means that the fuels get to dry out sooner. We're seeing more extreme weather with higher winds, for example. So all the factors that are known to help fires along are being exacerbated by climate change. So the real solution, of course, which is the elephant in the room that few people want to discuss, including the advocates for logging, is that we need to reduce the greenhouse gas emissions, CO2 in particular from fossil fuels, into the atmosphere. And that will, over the long haul, perhaps stabilize or reverse the warming trends that we're seeing that are so conducive to the spread of wildfires. And I want to add one more point there, too. Another misnomer about wildfires is they do put some carbon into the atmosphere, but ironically, and this gets back to the logging issue, logging and thinning actually contributes much more carbon to the atmosphere. A recent study just came out in Oregon, for example, and found that logging was the biggest contributor to greenhouse gas emissions in the entire state, bigger than transportation, jet planes, and all the other things we normally think about. So, again, it may be counterintuitive, but again, if you think about what burns in a fire, forest fire, you have the needles and the small fuels that are burning, and they have carbon, but a lot of the carbon remains on the site as snags and roots in the ground, as charcoal after a fire, and all that carbon remains on the site for a long time. It will gradually disintegrate and release carbon also, but it happens over a much longer time period, whereas if you go and log, immediately you're releasing much more carbon, and you're doing it right now, whereas we can't predict where a fire is going to happen, and so we can say that the logging is releasing carbon, leaving the forest alone. In fact, I would argue our best use of our national forests anymore is to have them as carbon reserves and not do any logging in them at all.
Yeah, so when somebody logs a forest, not only are they removing that carbon, but they are, releasing that carbon, but they are also reducing the capacity of that forest to sequester future carbon, since as forests age, they sequester more carbon annually. Older forests sequester more carbon annually than young forests. Exactly,
and that's a very good point. And even if the area burns, you have the carbon sequestered in the snags and in the roots, and you have young trees growing back. So the cumulative effects are actually much greater than, say, a clear cut or something, or even less radical thinning, which takes away all that carbon. And also, and people wonder about this, the accounting has to include the transportation, the trucks. When you make boards out of a tree, you have a lot smaller particles of wood that rot, or however you want to say, or release carbon through the life cycle. So that's why you wind up with a much greater loss of carbon through the logging thinning process than allowing a fire to burn, or even, again, the chances that any particular place will burn in a fire is very small probability. So we need to keep that in mind. The other part of it is, and this doesn't really address the question I asked there. We cannot log our way to less fires, but there's all this collateral damage that happens with logging that tends to be overlooked. I mentioned the one about how logging roads are a great vector for the spread of weeds and flammable plants into the ecosystem. But beyond that, we're removing biomass, and biomass, logs, live or dead, trees are very important to many plants and animals. In fact, one can make the argument that a lot of plants and animals live in mortal fear of green forests. So wildfires are one of the ways, including with bark beetles and other things, that we create inputs of dead wood into the forest ecosystem, which is critical to healthy forests. And then you have the removal of carbon. You have things like the disturbance of wildlife that may come with the logging operations. You have the sedimentation from logging roads that clog salmon and trout streams, and it's chronic. Even a wildfire within a few years, varies on the soil type, etc., but within a few years, usually after a fire, the sedimentation from the fire is reduced to pre-fire condition. And so, particularly like fish, they can deal with a few years of sedimentation, but logging roads are leaking sediment continuously. So they're a chronic source of sedimentation, which the fish and other wildlife are not adapted to. And that's why logging roads is such a problem for a lot of aquatic ecosystems.
And you said a moment ago that that snags are really important for habitat, and that many creatures, as you said, live in mortal fear of green forests. And that may be counterintuitive to people who don't know forests, and will be obvious to people who do spend a lot of time in forests. But can you make that explicit? So I've mentioned before that there, I live in a second growth forest, and there's a nice big Doug fir that got girdled by bears, and it's a beautiful, beautiful tree. And I've had the honor over the last 10, 12 years to watch this tree whiten. And so can you walk through the process of one particular snag in one particular place, from when the tree dies to why this is good for the forest? Why are dead trees actually a good thing?
Okay. Well, I'm going to start out with a statistic that's of interest, and that is the second highest biodiversity found in our western ecosystems are forests that have had high severity fire in them. In other words, a lot of dead trees. And this gets to the point that you're talking about, is there's a progression. First, you might, after a fire, have a whole bunch of beetles that invade the tree. And, insects are important. There's a lot of diversity in insects. Those insects then provide food for everything from birds, and we typically think of woodpeckers, but a lot of other birds feed on those insects that are attracted to a forest with dead trees. Everything from a nuthatch that might go up and down the bark to the experience of flycatchers and so forth that are catching insects that may be coming off of the trees and available for them to capture. And then you have, of course, the snags become holes and natural holes, as well as cavities made by woodpeckers and other animals become used for homes and nesting. And even the bark, when it starts to slough off a tree, and it's kind of flaky on there, bats, for example, roost under that in the daytime when they're roosting and not out hunting. And then when the tree falls onto the ground, eventually, it'll rot away and the roots will give way and it'll tumble over. And now you got a whole different set of characters that are utilizing ants, for example. A lot of ant species live in the downwood on the ground. Many of the native bees in the West are also dependent on downwood for their homes. And as an aside, I will mention that a recent study showed that after a wildfire, the diversity and abundance of native bees increases, presumably due to the two factors of a lot more wood for them to nest in, as well as often after a fire you get a big surge of flowering plants that provide more food to the bees. But nevertheless, the native bees are...
George, one more thing, too, I think, is that... I live in this dense forest here, and if you get without an opening, the bees don't really have a place to warm up. And
that's a very good point. Yes.
Okay, so go ahead. Just you need some openings for the bees too.
Yes, and then the logs on the ground are places that salamanders and small mammals hide under, and then as it rots even more, you might get different fungi, microfil. The names escape me right now. The filaments that will penetrate into the wood in the soil, mycorrhizal networks will penetrate that sort of rotting forest, and lichens and mushrooms are found often on that rotting wood, and each of those cast of characters have other animals and plants that feed upon them. So the diversity is greatly increased, and the complexity in a forest is greatly increased as you have more of that. And so all those things together, including, probably even soil bacteria, getting into the area I don't know much about, but down into the very soil bacteria and microflora are increased by the presence of down and dead wood. And then this is even true in the streams. A lot of the habitat in our western rivers and streams is created by logs that fall into the river. It slows down the erosion. It's a place that fish will, if you fish at all, right behind the log is a good place to cast your lure or fly, because the fish are staying there waiting. They don't have to work as hard behind that where the water's slowed by the log, and they'll dart out and get an insect or whatever. And there's also a lot of aquatic insects that increased from the input of all that wood into the stream. In fact, many fishery biologists I've talked to and hydrologists will tell you there's no upper limit to how much wood is beneficial to a stream ecosystem. In other words, the more wood, the better. And our source of wood, in many cases, tend to be these episodic events. And it's important to understand they're episodic. They don't happen year after year in any one place. They might be intervals of hundreds of years between an episodic event. So you may have a stand replacement fire that kills most of the trees, maybe once every 200 years. And then you don't have a lot of mortality in the intervening years. And that one wildfire may be responsible for the bulk of all the wood that is in that stream or on the ground for the next couple hundred years. And so we have to recognize that these episodic events are critical to the healthy functioning of the ecosystem. And a lot of the assumptions behind the logging and thinning is that we're going to create, I see it all the time, healthy, resilient forests. But the whole idea is to try to minimize things like wildfires or bark beetles, or the very things that actually create healthy forest ecosystems. It's a good example of a failure to see the forest through the trees. Most foresters are concerned about green trees, which is what's good for lumber. And they are so immersed in that kind of narrative and that idea that if a lot of trees are killed by any natural event, that's considered an example of an unhealthy forest, when in fact that is exactly what contributes to a healthy forest.
So I want to say one statistic before asking another question. The statistic is that you mentioned forest roads providing essentially infinite amounts or endless amounts of sediment to creeks. I actually have a number for that. A study showed that forest roads produce between 20 and 35 tons of sediment per acre of road surface per year. And 1 acre is about 0.6 of a mile of a logging road. So that's about a ton per year for every 100 feet. And of course, there are at least 440,000 miles of logging roads in the U.S. on national forest land alone.
Right.
Go ahead.
Yeah. Well, I'm just going to comment. That's the problem. We have so many miles of road, and they are a major source of sedimentation in our watersheds. And there's really, you can do a few things in road design and so forth that'll minimize that a little bit, but generally the thing is the more miles of road you have, the thicker the aquatic ecosystem's going to be, and the watershed is going to suffer.
So you and I have talked about this before, but I'd like for you to repeat it again, because I think what you're saying is so important and so counter to the narrative that is handed to us by the corporate media all the time and by politicians. Are fires the enemy of forests in the American West to be defeated?
No, that is exactly the problem. Our fires are what creates the diversity and the health of our ecosystems. And I want to make sure that it's clear that we have this whole narrative about low severity fires. In other words, the fires that don't kill trees and just kind of creep through the trees and so forth. There's a lot of people say, well, those are the, quote, good fires. And bad fires, quote, are the ones that kill a lot of trees. There's no such thing as a good or bad fire. That's just a total human value on it. And in fact, it's not scientifically informed either. The fires on the landscape, all fires, to one degree or another, have different influences but are ecologically important. And there is no such thing as a good fire or a bad fire. There's just fire. It's like saying, there's good wolves and there's bad wolves. And the wolves that eat elk are bad wolves, and the wolves that maybe eat white-tailed deer because you think there's too many of them, well, they're the good wolves. I mean, that's an absurd valuation that has nothing to do with the reality of ecosystem health or anything else.
And so, again, to make this clear, since there's so much disinformation, just could you please hammer for a moment the fact that the fires in the western United States, and presumably a lot of other places, evolved with fires, and fires are a necessary part of their life? I know you've said this, but we just can't say this enough.
No, and we have evolutionary evidence for that. And this is what gets overlooked a lot. Everything from blackback woodpeckers that are dependent on high severity, high mortality fires. They're attracted to the forest where most of the trees are killed. And that's just one example. There's more bluebirds in high severity fire areas than there is anyplace else, for example. And then a lot of fish, for example, after a fire, despite some of the sediment that comes in, there's also a lot of the coarse gravel necessary for spawning occurs after some of these high severity fires. And they're dependent on it. And we can go down through a list of all kinds of plants and animals. One study I'm aware of in Montana found that 40% of the mushroom species were most abundant after a high severity fire. And for the most part don't even show up if there isn't a major fire. So we have, this is all evolutionary evidence that plants and animals are adapted to these episodic events. And it's important, I think, for understanding that people have to understand that the climate, particularly if we're talking about fires, has a lot to do with these episodic events, and it's going to vary over time. So there have been periods of time, for example, the last century, between about the late 1930s through the late 1980s, almost a 60-year period, the climate around the western United States was cooler and moister than previous to that time and since that time. And there was a lot less fire on the landscape during that time, and forests got denser because they had higher successful seedling survival when it's moister and cooler and so forth. So you have these sort of trends that are influenced by the climate. And we can go back through time. One of the things I studied in graduate school was paleoecology and studied vegetation and fire too. And what you see is we've had periods of time that have been warmer than now and drier than now, and we've had times, of course, like the Ice Age and so forth, when it was cooler and moister. And that all influenced the vegetation that might be found in any particular region. And we tend to have a short-term view of things. We're looking at how fires are right now, and why there may seem to be more abundance. You hear this all the time. Oh, we're getting so much more fire now than we did. Well, it depends upon where your starting point is. If you're comparing it to the 1950s, 60s, and 70s when it was cooler and moister, that's completely accurate. But if you go back to, say, the 1920s and 30s, when between 20 and 30 million acres in one year, even 50 million acres, it's estimated, burned, and you compare that to a, quote, bad fire year these years of 10 million acres, you can see we actually probably have a deficit in terms of large fires. Now, we're never going to probably get back to 50 million acres because we got houses and roads and all this other stuff, but the point being is that depending upon where you're picking as your starting point, you can come up with an entirely different interpretation of what we're seeing right now.
So it sounds like you're suggesting that even what is called a sort of disaster fire year is not the number of acres that underwent what was the name of it? A stand-killing fire? What you used to?
Yeah, high severity fire. That's
a high severity
stand
fire.
Replacement.
Okay,
Yeah.
stand replacement fire. So even if you go just by the numbers, this last year was not the largest stand replacement fire acreage burned in a year that we know of. Is that correct?
Well, yes. Again, going back, depending upon how you look. For example, in 1910, a very famous fire called the 1910 burn burned between 3 to 3.5 million acres of Idaho and Montana. That's to give you a contextual framework for that. There's some of the big fires in California recently, like the Thomas Fire and the Carr Fire and so forth, are between 200,000 and 300,000 acres. So that one fire burned 10 times or more of the acreage of the largest fires that have occurred in recent times in California, and that was just one fire. We just don't have a good point of reference in a lot of this discussion. And I think if you look back now, I hesitate to downplay the fact that climate change is probably going to keep upping that amount of acreage. So we may quickly close that gap, and what we will, and because it's mostly due to our fossil fuel burning and other activities,
including deforestation.
Yes, and we are just going to probably see some radical changes in some of the vegetation, just as we have seen, and this is the predictive factor, just as we have seen in other periods of time when there have been significant changes in climate, whether it was cooler or moisture. And so what we have to, climate is, plant and vegetation is a direct reflection of the climate. And, if you dry out the climate and you make it warmer, you're going to have some significant changes in your vegetation. And then throw in that the things that we've contributed to it, like cheatgrass and the sagebrush ecosystem that burns much more frequently than the sagebrush grasslands before did, or, grasses that are invading into chaparral areas and increasing fire in chaparral so that they happen much more frequently. In other words, these things like chaparral and sagebrush are adapted to periodic fire, but not at the frequency that we are seeing due to these exotic grasses that have invaded them. So sagebrush, I'll use that as an example. Most sagebrush types, and there's a whole bunch of different types, so I'm sort of generalizing here, but most sagebrush species burn on an average of between 50 to 300 or 400 year intervals. And so they can burn and they can grow back if they're not having too much fire. But cheatgrass can burn every single year in some cases and still persist on the site. So if you had a fire in the sagebrush ecosystem every 5 or 10 years because of the presence of cheatgrass, the sagebrush just cannot tolerate burning that frequently and will disappear from the site. And that's what we're seeing in some ecosystems, is that fire is actually too frequent compared to how it was in the past. On the other hand, a lot of these ecosystems around the West had very long intervals between fires, and still do. So they don't burn that frequently, despite the fact that we're aware of them. So you have something like Yellowstone is a classic example. The fire interval there is anywhere from 100 to 400 or 500 years, depending upon where you're talking about in Yellowstone on the forested areas. And, and so in general, fire doesn't occur very frequently there. And in most summers, you could go in there with a blowtorch and you wouldn't be able to get a fire to burn because it's too moist most of the time for a large fire to occur. So we have a lot of forested areas that don't burn very frequently when you have the right conditions. And as I mentioned them before, low humidity, high temperatures, drought, and wind, you can get a large fire. The thing is you don't have those conditions in any one particular place all that often. And we may get an impression from the news media that the entire West is burning up, for example, because we'll hear about the larger fires and we're aware of them. but in terms of the landscape as a whole, they may not influence that much of the vegetation communities in any one year.
So California has pledged to spend a boatload of money to protect our forests through cutting them down, basically to, quote, fight fires by increasing logging. And you hear calls from politicians all over the place saying, we need to stop the forest fires, we need to cut. So is there, given that fires are a necessary part of forests, and given that these fires are smaller than, for example, the Idaho fire you mentioned earlier, why is this narrative pushed so hard? Is it simply to help the logging companies? Is it because this culture hates forests and hates wild nature that's not controllable? Is it because fires hurt and so they're kind of scary? Like if my house is on fire, that's a scary thing. Or if somebody comes after me holding a torch, that's a scary thing. Why is there this incessant and powerful propaganda saying we need to deal with fires?
Well, I would attribute that to a number of factors. One, there is the industrial forestry paradigm that sees any dead trees, or when I say any, they'll always quip that we're not again. There's some dead trees is good, but any large number of dead trees is considered bad, and that comes from the forestry. Industrial forestry narrative that's taught at forestry schools and is widespread in a lot of the agencies. So there's that factor. Another factor is that there's a sense, and it's a false sense, as I've tried to imply, that we can control these fires. And basically under the extreme fire weather conditions, you cannot control fires. But there still is that widespread idea that, because you can go in under less than severe fire conditions, like I said, when it's kind of wet or there's not drought or something like that, and you can put the fire out pretty easily. In fact, probably if you left it alone, the fire would go out on its own. But we take credit for it. So we presume we have the ability to control these fires, even though there's a whole lot of research out there, including coming from Forest Service fire ecologists, who say that under extreme fire conditions, weather conditions, we cannot control the fires. But there's this impression that we can. And a third factor, I think, that contributes to it is, people have gotten used to it. Again, this is a shifting baseline. Like I mentioned, all through the 1930s through the 1980s, which is the lifespan of almost everybody that's alive, older people now, there wasn't a lot of fire out there. And so that became the norm. And the people that experienced all the fires earlier in the 1910 burn or whatever are dead. So our point of reference is this period of time when there was fewer fires. And then the final thing that I think contributes to it is a political agenda too, which is, as I said, one of the things that's driving this is climate change. And there's as you know, a big segment of the political arena, at least, that does not want to acknowledge that climate change is the result of humans, and that we are contributing to these factors that increase things, everything from fires to hurricanes. And the irony is, none of us think that we're going to stop earthquakes or hurricanes, at least not yet. But we have this impression that we can stop the fires. But the large fires are operating at a scale and due to influences that are much beyond our control, at least our immediate control, in the sense that, if it's a drought year and the wind's blowing, there's not much we're going to be able to do about those factors, and that's what will cause a large fire. In the long term, reducing climate change's warming will make a difference. But that, even if we got on it tomorrow to try to reduce our CO2 emissions and so forth, that we won't see the effects of that for many, many decades. And so basically, we're kind of stuck with this scenario unless something else unforeseen happens, major, volcanic eruptions that cool the climate of the whole Earth maybe for, several decades or something. That might stop the wildfires. Has other consequences, of course, but that's the only thing that I can see that's going to change this scenario. So we are going to have to learn to live with the wildfire, and there's two parts of it that make it hard. One is houses burning down. There's a lot we can do about that. It's lots of science showing that if you reduce the flammability immediately around your house and doing things like putting metal roofs on and keeping firewood away from the edge of the house, doggy doors, by the way, is a funny thing. Remember, high winds is what drives fire. Doggy doors let embers get blown into a house and burn the house down. So there's things that you can do that will, greatly enhance the ability to withstand fire. And that's where we ought to be focusing our attention. The other part of it is the smoke, and that's a continental thing. I'm in Ashland, Oregon right now at a meeting, and the big thing was for 8 weeks there was a lot of smoke in Ashland. And there were some local fires, but most of the smoke actually was coming from fires up in British Columbia and down in California. So it wouldn't matter what you did in terms of thinning around Ashland. It's being sold if we thinned around Ashland we could reduce the smoke, but that's just delusional. I was in the Rockies for a lot of the summer, and there were not very many fires in Montana and Wyoming at the time I was there, but there was a lot of smoke coming from California. So it wouldn't matter what you did in Montana in terms of thinning if you think that's going to reduce smoke, because it isn't. It's a continental-wide situation with the smoke, and there isn't a whole lot you can do about it, frankly, except change the climate. And we've got to do something about that climate change if people want to see a reduction in some of those effects.
So I am not sure what you feel about how mechanistic a scientist you are. So please don't object to my word want. If we exclude global warming from this, what do forests want in terms of fire?
Well, it all depends on the vegetation type. Kind of getting back to the evolutionary influences that I mentioned earlier, we look at different trees and they have different strategies for dealing with fire. So, something like ponderosa pine, which many people may be familiar with, it grows at lower elevations in drier forests. It tends to have what's called self-pruning, so it loses a lot of its lower branches. It has a very thick bark that gives it some resistance to fires that are not particularly hot. It also has bark that pops off as it heats up. So just about the time when the bark is about to catch on fire, it pops off. So it has all these evolutionary adaptations to fires that are not particularly hot or big, fires that have a lot of high mortality, that are burning under the extreme fire weather conditions. But under more moderate weather conditions, it can survive through those kinds of fires. On the other hand, you have lodgepole pine, which I mentioned is common in Yellowstone Park. It has very thin bark. It doesn't try to survive a fire, and it makes sense to invest in thick bark in a place where, due to the climate conditions where lodgepole pine grows in Yellowstone, high elevation with heavy snowfall, the chance of a fire occurring is very low. So why invest in trying to deal with that? And when it does have a fire, it only occurs during these extreme fire weather conditions when you get a high mortality. So it doesn't try to save itself at the fire, except that it does have cones that are called serotinous cones, and not all trees have serotinous cones, but a significant amount of them do, that will only open after they're heated. And those serotinous cones are an adaptation to periodic, episodic kind of fires that may not happen very often, but when they do, then the lodgepole pine sets a lot of seeds so it can regenerate quickly on the site. It has another adaptation. It's very precocious, so to speak. Within 5 to 6 years, the lodgepole pine, young lodgepole pine, is producing viable cones. So it quickly can, and often those early cones are not serotinous, so they drop more seeds on the site. and then pretty soon you've got tons of lodgepole pine growing there. By contrast, the other forest species might not produce mature cones until they're 50 or 70 years old, but they're not the ones that are set to colonize right after a fire. They are more species that tend to come in after there's a lot of shade, when there's even less chance of a fire because it's moist and cool. So, this evolutionary adaptations, the plants have them depending upon what was the common fire regime or influence on that landscape. And so long as we're within that kind of situation, the forest can readily adapt it to it. And I might add that, for example, the ponderosa pine had or adapted to these light severity fires, low severity fires that didn't kill trees, but that doesn't necessarily exclude the possibility of a high severity fire, not very frequently, but maybe every 100 or 200 years in ponderosa pine ecosystems. So, but again, the ponderosa pine is adapted to dry, hot sites, so it often comes back on those sites if there's any seed source left after a fire.
That is all so beautiful what you just said, and it reminds me of two quick stories. We have like 5 minutes left, but I want to tell these two stories really quickly. One of them is I was asking a wildlife biologist friend of mine who works for the Forest Service, what is the evolutionary purpose of bears girdling trees? How does that help the forest itself? And he didn't know. I mean, he hasn't done studies, but he himself lives in a mixed tan oak Doug fir forest. And he said Doug firs grow faster, they reproduce more quickly, they basically have every evolutionary advantage except for the fact that bears like them. So what that does is bears like to eat them. And so what that does is that allows the tan oak to mix into the forest. Because if there weren't bears killing the trees, there'd be nothing but Doug firs. That's one story. And the other story is that same biologist, he and I were sitting looking at the ocean one day, and he mentioned to me that sharks, the roughness of a shark's skin is perfect for it to create turbulent flow around it to decrease the friction as it goes through the water so as to maximize speed. And when he said that to me, I looked at him and I said, so do you believe in some sort of intelligent design? Do you believe in some sort of God or something that creates all this? And he looked back at me and he said, there is great intelligence in time. And I love that. And so when you tell me stories like the ponderosa pine pops its bark off, it's like I marvel again at and it doesn't matter whether we think it comes from some being or whether it's time. It doesn't matter at all. I just am amazed at the extraordinary intelligence and complexity of any natural community, and the sort of the folly of thinking that we know better what a forest needs than the forest does.
Right. No, and this is the other thing, and a very important point, if we got a few seconds left, is that
we do.
There's great genetic diversity within the forest. So, for example, there's been some recent studies done both at ponderosa pine, in whitebark pine, in lodgepole pine, that shows within any stand you have a certain amount of diversity. And I'll use lodgepole pine because I've read the most studies on that. But there are within any, if you took 100 lodgepole pine and looked at their genetics and their ability to survive different conditions, there are some within that stand that actually grow better and are more resistant to drought than others within that stand, which actually grow better under moisture, cooler conditions. And within any one stand, there's going to be this sort of ebb and flow of which trees are dominating on the site depending upon long-term climate cycles. So if you had, a couple of centuries of drought, you would find that part of the genetic code in lodgepole pine would be favored. probably not to the total exclusion of all the cool ones which find their little microsites to survive in, but you would get over time more of that genetic dominance. And it turns out, for example, that the adaptation to drought also is an adaptation to bark beetles, because the way that ecological pine resists bark beetles is by using their sap to push out bark beetle eggs and larvae. And that's their major defense, so long as they're not overwhelmed. And so the same trees that are genetically adapted to drought have this other resistance to bark beetles as well. And I always make the point to when I go out on these collaboratives and stuff, that they usually have a prescription where they say, we're going to take out 50% of the trees, but they have no idea what they're destroying in that prescription, in the sense that a lot of those trees may have genetic adaptations to all kinds of things that we're not even aware of, much less things that we are, like drought or bark beetles. And so that is one of the reasons why when people talk about they want to restore forest health, or they want to restore the forest, and the way they want to do the restoration, which is so common, is to log it. I'm saying you don't know what the hell you're doing. You may be actually impoverishing that forest ecosystem, because a lot of, particularly the genetic adaptations to situations may not be quite as easy to spot as bark beetles or drought. There may be only one tree out of 100 that has an adaptation to some particular situation, and would then spread through that population if that kind of situation were to manifest itself on the forest stand. So we are, by logging the forest, often, whether it's clear cutting or thinning, taking away some of that genetic stuff. And the thing is even in something like a wildfire, which may have high mortality, we just don't know that some of the trees that might not be burning up might be ones that have some sort of genetic resistance to fire. Maybe they have slightly thicker bark, for example, or other adaptations that we're just totally unaware of. So I'm not ready to say that that logging ever restores a forest ecosystem, because I think we're sort of blind to what's going on there, and we have no idea what's important in the long term. I mean, a good example is, for a long time ago, it was not uncommon to rip logs, big logs, out of a stream, thinking that was going to help salmon and trout, and then it was learned, oh no, actually the logs are important for habitat, and now they pull logs back into it. So that's an example of where our assumptions were totally incorrect, and the opposite was true. And I think we have so much of that still occurring, and all sorts of things that we're totally unaware of.
So we're pretty much out of time, but if you have, how can people resist this narrative is so overwhelming that stop fires. What can people do to resist that narrative, apart from interview you?
Well, I think I would want to shift the narrative to the degree that we can, to focus on homes and community, that we can ensure that a lot of places will not burn down by changing some of the laws and regulations. For example, building way out on rural landscapes increases the chances of fire for lots of reasons. Trees blow down over a power line, and suddenly you got a fire going. So things like zoning, things like putting metal roofs on your homes and so forth, start at the community and house level. There's so much work that can be done there, and before we ever get back out into the forest. And I think if you can make people feel safe, they are going to be much more accepting of fire in the out in the hinterlands. That the fear of fire dominates right now. So we have to reduce that fear, and then the other part of it is, like I've said, is to point out that the whole scenario that logging will preclude these large fires is delusional, and it's ineffective, and it's inefficient, and it has much collateral damage to the forest ecosystem. So, just hitting that home, those two things. But the thing that might sell to people, at least in the short term, is working on trying to make communities safer and less likely to be affected by a fire. And the analogy I might make to that is we're not going to stop earthquakes, but we've reinforced bridges, we've made hospitals and other buildings safer if there is an earthquake. That's what we got to start doing in terms of fire. And we're not going to stop earthquakes, and we're not going to stop fires.
Well, thank you so much for all of your work, and thank you so much for your sanity. And I would like to thank listeners for listening. My guest today has been George Wuerthner. This is Derrick Jensen for Resistance Radio on the Progressive Radio Network.